Okay, welcome to lesson 7 of the electricity module P1. Today we're going to be looking at light-dependent resistors and thermistors. A lot quicker than the previous lesson, this one. So, have you ever wondered how a street light knows when to come on? We could put it on a clock, but it changes when it gets dark. I mean, it's dark at 4 o'clock in the winter, but it doesn't get dark till 10 o'clock in the summer. So, does someone have to keep changing the clock? Well, no. It turns out that on the top of each one is a little light dependent resistor. So let's draw the symbol. We call them LDRs because it's just a lot to say each time. So an LDR is a resistor, like so, and it's inside a circle and it's being shot by light. So that's what the arrows are. Some pictures have 2, some have 3 arrows. It really doesn't matter. So that's an LDR. And the reason I'm teaching that at the same time as thermistors, and again I could ask you, how does a kettle know when to turn off when it gets to 100 degrees? Well, how does it know it's at 100 degrees? Well, it turns out that inside is a thermistor. Again, a resistor, but this time you just draw a hockey stick or a golf club through, like so. And again, don't worry too much about which way it goes, that kind of thing. That's the correct way, but if you get it a little bit wrong, but you still draw the stick and the bit at the bottom, you'll get the marks. So we're going to draw the graph for both of these. Now, normally, if we're inside a lesson, we do a nice little experiment where we have a light bulb, like so. And we'd have the LDR mounted on a bit of wood here. There's the LDR. And we change the amount of light going into the LDR. And we could measure the resistance of the light dependent resistor. We plug it into what's called a multimeter, and that would give me a reading about what the resistance is, like that. And we could plot a little graph. The graph's nice and easy, so let's hop over to that. Nothing tricky at all. None of that minus stuff this time. We'll keep it simple. And we can have light along the bottom and resistance in ohms up the side. And what we get, I nickname it a skate ramp. We get it dropping down very quick and then it comes across like that. So we can write a sentence. Remember, pause anytime you need to. As light increased, and remember we use a word for that, it's brighter. As light increased, it got brighter. The resistance decreased. So, key points here. As the light goes up, the resistance went down. So that's an LDR. And there's a really good reason I do these two together, because you get exactly the same answer. So if I now do this and I put that there, come to that in a minute. And here, this time I add temperature. So in this one, I just get a beaker of water. I pour in hot water, like that. Then I put the thermistor inside it, which sounds crazy. Why would you put electricity in water? But it works. And there's it's usually green in real life. It's a little green thing. There it is. And again, I just plug it into a multimeter and I measure the resistance like that. And guess what? You get exactly the same answer. We get a graph that starts high, and as it gets hotter, the resistance goes down. So we can write that in. As the temperature increased, again we have a word for that, got hotter, the resistance decreased. Make sure you got those sentences in. Key points again. Temperature went up, resistance went down. Now, you may have caught a glimpse at what's on next. I have a little method that helps me remember this and also helps me further on when it talks about what happens to the current and the voltage inside these components. And I call it the Thunderbirds method. Ask your parents. Now, the reason I say that is if you held both hands out and you walked like you were a puppet, then one hand would go up while the other hand went down. And then swap hands, one hand goes down, the other hand goes up. And it's that constant changing as one goes up, the other goes down. And I nickname it, in my head, the Thunderbirds method. And I'll show you what I mean by that. Let's go back to the LDR. I'm going to write down light. And underneath it, I'm going to write down resistance. So you sat in the exam a year and a half from now, and the question says, describe what happens to the resistance as the light decreased. So you put one hand out, your left hand, for example. If the light goes down, then your left hand goes down. Which way was your right hand going? Your right hand would go upwards. So we would write out a sentence. As the light went down, the resistance went up. Let's try it for a thermistor. Thermistor. Okay, and the question is, as the temperature went down, and by now you know it straight away, what happened to the resistance? Resistance went up. Thunderbirds method. But you can go one further. What if they then said, and describe the current? So let's put current for both. Current and current. Okay, so the question now says, as the light went down, describe what happened to the resistance and the current in the LDR. Well, it's the same thing. Left hand. As the light goes down, the resistance goes up. If resistance goes up, then the current goes down. Thermistor. Describe the resistance and the current in a thermistor as it gets colder. Okay, left hand. As the temperature goes down, the resistance goes up. If resistance goes up, then the current goes down. So now you can jot those in the corner of your exam paper, that you can write them out in a full sentence so you'll get it correct. And we can go one further. What about if it said, what about the voltage? What is the voltage that it takes from the circuit? We talked about them stealing the energy, so voltage is the energy taken out. Can you guess which way these two voltage arrows are going to go? I bet you can. And hopefully you've gone upwards. So, to put it all together, in an LDR, as the light goes down, the resistance goes up. If resistance goes up, then the current goes down. If the current goes down, then the voltage goes up. Thunderbirds. So, have a go by yourself. What about now if it was really, really bright? Bright light. Can you write out for me a full sentence that describes the resistance, the current, and the voltage? Press pause, have a go, write the sentence out here, blah, 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 and then press play in a minute and I'll give you the answer just to check. And you probably haven't, and you're just waiting for me to give the answer. But here we go. So, in a bright light, the resistance goes. So at this point, I would find a little spare bit of paper somewhere. I'd double check, I'd write it little, and I'd write L for light, R for resistance, I for current, V. Bright light. As the light goes up, resistance goes down. As the resistance goes down, the current goes up. And if the current goes up, then the voltage goes down. So now I can do it really easy and I guarantee myself all the marks. So, in a bright light, the resistance goes down. So the current goes up. Therefore, got to sound posh, therefore the voltage, and we'll say taken because it takes the voltage away, taken is low. And there we go. So we've got bright light, the resistance goes down, the current goes up, the voltage goes down. And that would be a good 3 or 4 mark question. Really easy to do. Just think Thunderbirds. And that concludes this lesson. Cheers.